Hello, in this lecture we'll find out the radius of the circle. In the drawing we have a circle. Inside the circle we have chord AC that is equal to square root of 2 units, chord DB equals to 2 units in its length, and this angle DEB equals to 45 degrees, and our mission is to find out the radius of this circle. So we'll use two rules in order to solve this question. The first rule is that the central angle is twice as big as the peripheral angle resting on the same chord. Then we have the peripheral angle AOB equals to alpha, and it rests on chord AB. Therefore, the central angle AOB that rests on the same chord AB must be twice of the peripheral angle. That is to say, it must be equal to 2 alpha. Okay, so always the central angle is twice as big as the peripheral angle that rests on the same chord. Okay, yeah, the central angle AOB equals to 2 times of central angle AO, and this and the peripheral angle AOB, it is equal to alpha. Therefore, the central angle equals to 2 alpha. Okay, and we also have the law of cosines. According to the law of cosines, in any triangle ABC could be any triangle. The length of side AB is A units, side AC equals to B units in its length, and this side BC equals to C units in its length. Then in this triangle ABC, C square equals to A square plus B square minus 2 times A times B times cosine theta. So from this equation it is very easy to arrive to this equation, that cosine theta equals to A square plus B square minus C square over 2 times A times B. Again, cosine theta equals to A square plus B square minus C square over 2 times A times B. Okay, so first of all, we define the center of this circle, this point, as O. In the next step, we will join points O and B, points O and D, points O and A, and points O and C by straight line. So actually, all those 4 line segments, OB, OD, OA, and OC, are the radii of this circle, because of the fact that they start from point O and end at points B, D, A, and C that are the points on the circle. This is exactly the definition of a radius. So we define the radius of this circle as capital R. Therefore, OB equals to capital R, OD equals to capital R, OA equals to capital R, and finally CD or OC equals to capital R. Okay, we focus on the straight line AB. On the straight line AB, at point E, we have this angle that is equal to 45 degrees. Therefore, the missing angle AED must be equal to 135 degrees according to rule number 1, that the sum of the angles on one side of a straight line is equal to 180 degrees. So if you focus on the upper side of the straight line AB at point E, the sum of the angles must be equal to 180 degrees. So which angles we have? Here we have angle 45 degrees plus the missing angle AED. In total they must be equal to 180 degrees, therefore the missing angle must be equal to 135 degrees in order to complete the sum of the angles of the straight line AB at point E. The upper side to 180 degrees, this angle must be equal to 135 degrees. Okay, we define angle ADC, this angle as y over 2. So the peripheral angle ADC rests on chord AC, and according to our definition, it is equal to y over 2 degrees. Therefore, the central angle that rests on the same chord AC, and the central angle AOC rests on the same chord AC, must be equal to y over 2 over times 2, twice as big as this angle, that is y over 2. That is to say, this angle must be equal to y. Okay. Likewise, we'll define angle BAD, the peripheral angle BAD, this angle is x over 2. The peripheral angle BAD rests on chord BD, and it is equal to x over 2. Therefore, the central angle DOB that rests on the same chord must be equal to x. Okay. In the next step, we'll focus on the green triangle AD. On the green triangle AD, the sum of the angles must be equal to 180 degrees. It is true in any triangle, and especially in triangle AD. Okay. So which angles we have? Inside triangle AD, we have this angle that is x over 2. Plus this angle that is y over 2. Plus this angle that is 135 degrees. In total, they must be equal to 180 degrees. Okay. So here we have the sum of the angles of the green triangle AD equals to 180 degrees. Okay, so we subtract 135 degrees from this equation. And you will get that x over 2 plus y over 2 equals to 180 degrees plus 135 degrees is 45 degrees. We'll multiply this equation by 2 and we'll get that 45 degrees times 2 is 90 degrees. Equals to x over 2 is x plus y over 2, x times 2 is x plus y over 2 times 2 is y. So we found out that x plus y equals to 90 degrees. Therefore we subtract. So here we subtract x from this equation and we get that y equals to 90 degrees minus x. So y equals to 90 degrees minus x. In the next step, we'll focus on the pink triangle ODB. The pink triangle ODB. According to the law of cosines, we get that cosine x equals to r squared plus r squared times minus 2 squared, that is 4, so it is minus 4, r squared plus r squared minus 4 over 2 times r times r. So this equation number 1 is the implementation of the law of cosines on the pink triangle ODB. Okay, so cosine x equals to r squared plus r squared is 2r squared minus 4 over 2 times r is 2r squared. So cosine x, here we split this side of the equation into 2 parts. So the first part will be 2r squared over 2r squared, and the second part will be minus 4 over 2r squared So cosine x equals to 2r squared over 2r squared is 1. Minus, here we have minus 4 over 2 is minus 2. So in the numerator we have minus 2. In the numerator we have minus 2. In the denominator we have r squared. So in conclusion, we found out that according to equation number 1, cosine x equals to 1 minus 2r squared. In the next step, we'll implement the law of cosines in the yellow triangle AOC. in the yellow triangle, triangle AOC. According to the law of cosines, we get that cosine y equals to r squared plus r squared minus square root of 2 squared. Square root of 2 squared is 2, so it is minus 2 over 2 times r times r. So according to equation number 2, we found out that cosine y equals to r squared plus r squared minus 2 over 2 times r times r. So according to equation number 2, we found out that cosine y equals to r squared plus r squared is 2r squared minus 2 over 2 times r is 2r squared. So cosine y equals to, we split this side of the equation into two parts. The first part will be 2r squared over 2r squared, and the second part will be minus 2 over 2r squared. So cosine y equals to 2r squared over 2r squared is 1. And here minus 2 over 2 is minus 1, so in the numerator we have minus 1, in the denominator we have r squared. So in conclusion, we found out that according to equation number 2, cosine y equals to 1 minus 1 over r squared. We have already found out that y equals to 90 degrees minus x. Again, y equals to 90 degrees minus x. So we substitute cosine y in this equation number 2 by 90 degrees minus x. And we get that cosine y equals to cosine, and y is 90 degrees minus x, so here it is 90 degrees minus x. And we have the trigonometric identity that states that cosine 90 degrees minus alpha equals to sinus alpha. So we substitute cosine 90 degrees minus x by sinus x. In conclusion, we found out that cosine y equals to sinus x. Therefore, we substitute cosine y in this equation number 2 by sinus x. And we get that according to equation number 2, cosine y is sinus x equals to 1 minus 1 over r squared. And we have already found out that according to equation number 1, cosine x equals to 1 minus 2 over r squared. We have two equations here. In the next step, we will define 1 over r squared as t. 1 over r squared equals to t according to our definition. And we substitute 1 over r squared in both equations, 1 and 2, by t. And you get that according to equation number 1, cosine x equals to 1 minus 2 times 1 over r squared. And 1 over r squared is t, so it is 1 minus 2t. And according to equation number 1, according to equation number 2, sinus x equals to 1 minus 1 over r squared is t. So we substitute 1 over r squared is t. So in conclusion, we found out that according to equation number 2, sinus x equals to 1 minus t. In the next step, we'll use the trigonometric identity that sinus squared theta plus cosine squared theta equals to 1. So according to this trigonometric identity, we have sinus x equals to 1 minus t, therefore sinus square x will be equal to 1 minus t squared. And we have also here plus cosine square x. Cosine x equals to 1 minus t, therefore cosine square x will be equal to 1 minus 2t squared. And according to this trigonometric identity, it is equal to 1. So if I found out that according to this trigonometric identity, sinus square theta plus cosine square theta equals to 1, 1 minus t square plus 1 minus 2t square equals to 1. So we'll open the brackets on this side of equation number 1. And we find out that according to equation number 1, according to this equation number 3 actually, 1 minus t squared equals to 1 squared, it is 1, plus t squared minus 2t plus 1 minus 2t squared equals to 1 squared, it is 1, plus 2t squared, that is plus 4t squared, minus 2 times 2t is minus 4t. And it is equal to 1. So we have here 4t squared plus t squared is 5t squared. Minus 2t minus 4t is minus 6t. And here we have 1 on both sides of the equation, so 1 will get cancelled. And we also have this 1, so it is plus 1, that is equal to 0. Okay, in the next step, we'll substitute minus 6t by minus 5t minus 1t. In this equation number 3, we get that 5t squared minus 6t is minus 5t minus 1t plus 1 equals to 0. In the next step, we take out a common factor of 5t from those two expressions, and we'll get that what is left from 5t squared after we took from it 5t as a common factor, what is left is actually t, and here we have what is left from minus 5t after we took from it 5t as a common factor, what is left is actually minus 1, and we also take a common factor of minus 1 from minus t from plus 1, so what is left for minus t after we took from it minus 1 as a common factor, what is left is actually t, and what is left from 1 after we took from it minus 1 as a common factor, what is left is actually minus 1. Why? Because minus times minus is plus. So here we get plus 1. And it is equal to 0. In the next step, we take out t minus 1 as a common factor from those two expressions. And we'll get that according to equation number 3, so t minus 1 is taken out as a common factor from those two expressions. So what is left from 5t times t minus 1 after we took from it t minus 1 as a common factor, what is left is actually 5t, and what is left from minus t minus 1 after we took from it t minus 1 as a common factor, what is left is actually minus 1, and it is equal to 0. So here we have two solutions that are possible for this equation. Either t minus 1 equals to 0, and the second possibility for the solution of this equation is that 5t minus 1 equals to 0. So, according to the first solution, t minus 1 equals to 0, it means that t equals to 1. And according to our definition, t equals to 1 over r squared. So we substitute t by 1 over r squared in this equation, and we get that 1 over r squared equals to 1. We'll multiply this equation by r squared, and we'll get that r squared equals to 1. We'll take a root of this equation, and we'll get that r equals to the square root of 1. The square root of 1 is either minus 1 or plus 1. So r could be equal to either minus 1 or plus 1. But because of the fact that r is a length, and a length cannot be a negative number, the solution that r equals to minus 1 will be cancelled. It is not correct, and we left only if r equals to 1. Then we have the second solution to this equation, equation number 3, that 5t minus 1 equals to 0. That is to say 5t equals to 1, we divide this equation by 5, and we get that t equals to 1 over 5. Again, according to our definition, t equals to 1 over r squared, so we substitute t in this equation by 1 over r squared, and we get that 1 over r squared equals to 1/5. We cross multiply this equation, and we get that r squared equals to 5. We take a root out of this equation, and we get that r equals to the square root of 5. So we have here two solutions. Either r will be equal to the positive square root of 5, or r also could be equal to the negative square root of 5. But r equals to the negative square root of 5 is not correct. It is not possible because r is a length, and a length must be a positive number, so r equals to negative square root of 5. It is not correct. It it is not correct, we cancel the solution and we left only if r equals to square root of 5 units, or the second solution is that r equals to 1. Okay, so in the drawing we have here chord dB is equal to 2 units. This chord dB doesn't pass through the center of this circle, that is to say it doesn't pass through point O, and therefore it is not the diameter of the circle. Chord dB is not the diameter of the circle. Why? Because any diameter of a circle must pass through the center of the circle, that is to say from point O. And we know that the diameter of the circle, that is 2r, is the longest chord in the circle. Therefore, the diameter of 2r must be greater than chord dB, that is not the diameter. I write it down. The diameter 2r must be greater than dB. Repeat again. 2r must be greater than dB. It is given us the question that dB equals to 2 units, therefore we substitute dB by 2, and we get that 2r is greater than 2. Okay, dB is 2. We divide this equation by, we will divide this inequality by 2, and we get that 2 over 2 is r, greater than 2 over 2 is 1. So we found out that the radius of our circle must be greater than 1 unit. So the solution that r equals to 1 is not correct, because r must be greater than 1. So we cancel the solution and we left only with the solution that r equals to the square root of 5 units. R equals to the square root of 5 units. Or in terms of numbers, it is equal to 2.236 units. So finished with the question. Repeat again. The radius of this circle r equals to either square root of 5 units, or in terms of numbers it is equal to 2.236 units. In the next step I will summarize the lecture. In this lecture we found out the radius of this circle. Okay, we know that chord dB equals to 2 units, chord AC equals to the square root of 2 units, and this angle angle DEB equals to 45 degrees. Our mission is to find out the radius of this circle. We use two rules in order to answer to this question. The first rule is that the central angle is twice as big as the peripheral angle that rests on the same chord. Here we have the peripheral angle ACB equals to alpha. Therefore, and it rests on chord AB. Therefore, the central angle AOB that rests on the same chord AB must be twice as big as the peripheral angle ACB. And because of the fact that angle ACB equals to alpha, it means that the central angle AOB must be equal to 2 alpha. Okay? So, the central angle is twice as big as the peripheral angle that rests on the same chord. And we have also the law of cosines. According to the law of cosines, we have triangle ABC that could be any triangle. In this triangle ABC, the length of side AB is equal to A units. Side AC equals to B units in its length, and side BC equals to C units in its length. Then according to the law of cosines, the following equation is true. that c square equals to a square plus b square minus 2 times ab times cosine theta. Again, c square equals to a square plus b square minus 2 times ab times cosine theta. From this equation, it is very easy to arrive to this equation, that cosine theta equals to a square plus b square minus c square over 2 times a times b. Okay? So, in the first step, we define the center of this circle, this point as O. Then we joined points O and B, points O and D, points O and A, points O and C together by a straight line. Those 4 line segments are the radii of this, the radius of the circle. Why? Because they start from the center of the circle and ends at points B, D, A and C that are the points on the circle. And this is exactly the definition of a radius. Therefore, OB equals to OD equals to OA equals to OC. They are all the radii of this circle that is equal to capital R according to our definitions. Okay? In the next step, we focused on the straight line AB. The straight line AB, this angle equals to 45 degrees. And therefore, the missing angle must be equal to 135 degrees according to the rule that the sum of the angles on one side of the straight line is equal to 180 degrees. Therefore, the sum of the angles on the upper side of the straight line AB at point E must be equal to 180 degrees. So, if this angle is 45 degrees, the missing angle must be equal to 135 degrees according to the rule that I mentioned. Then, here we have peripheral angle ADC that is equal to y over 2. And therefore, the central angle AOC that rests on the same chord AC must be equal to y, because it is twice as big as the peripheral angle that is y over 2. Then we have the peripheral angle DAB, this peripheral angle equals to x over 2 according to our definition. Therefore, the central angle DOB that rests on the same chord, DB, must be equal twice as the peripheral angle that is equal to x over 2. Therefore, this angle must be equal to x. Why? Again, because both of those two angles, the peripheral angle and the central angle, rest on the same chord called DB, according to the rule that I mentioned in the beginning of the lecture. Okay? So, in the next step, we focused on the right green on the green triangle AED. We have the rule that the sum of the angles in any triangle is equal to 180 degrees, and therefore the sum of the angles in triangle AD must be equal to 180 degrees. Which angles we have here? We have x over 2 plus y, x over 2, y over 2 plus 135 degrees equals to, must be equal to 180 degrees according to the rule that I mentioned. Again, in the green triangle AD, x over 2 plus y over 2 plus 135 degrees must be equal to 180 degrees. We subtracted 135 degrees from this equation and found out that x over 2 plus y over 2 here in this side of the equation equals to 180 degrees minus 35 degrees is 45 degrees. Okay, so we multiply this equation by 2. 45 degrees times 2 is 90 degrees. X over 2 times 2 is x, y over 2 times 2 is y. So here in this side of the equation we have x plus y equals to 90 degrees. In the next step we subtracted x from this equation and found out that y equals to 90 degrees minus x. In the next step we implemented the law of cosines in the pink triangle, triangle DOB. In the pink triangle, triangle DOB, according to the law of cosines, cosine x equals to r square plus r square minus 2 square over 2 times r times r. Repeat again. In the pink triangle, triangle DOB, according to the law of cosines, cosine x equals to r square plus r square minus 4 over 2 times r times r. So cosine x equals to r square plus r square is 2r square minus 4 over 2 times r is 2r squared. Then we split this side of the equation into two parts. So cosine x equals to, the first part is 2r squared over 2r squared, and the second part is minus 4 over 2r squared. So in conclusion, we found out that cosine x equals 2r squared over 2r squared is 1, and here we have minus 4 over 2 is minus 2, so in the numerator we have minus 2, in the denominator we have r squared. So in conclusion, we found out that according to equation number 1, cosine x equals to 1 minus 2 over r squared. In the next step, we implemented the law of cosines on the yellow triangle, triangle AOC. On the yellow triangle, triangle AOC, cosine y equals to r squared plus r squared minus square root of 2 squared. Square root of 2 squared is 2. Okay, so cosine y equals to r squared plus r squared minus 2 over 2 times r. Repeat again, on the yellow triangle, triangle AOC, cosine y equals to r squared plus r squared minus 2 over 2 times r. So cosine y equals to r squared plus r squared is 2r squared minus 2, and here 2r times r is 2r squared. In the next step we splitted this expression, this side of the equation, into two parts. So here we have cosine y equals to, the first part is 2r squared over 2r squared, and the second part is minus 2 over 2r squared. So cosine y equals to 2r squared over 2r squared is 1, and minus 2 over 2 is minus 1. So in the numerator we have minus 1, in the denominator we have r squared. So according to equation number 2, we found out that cosine y equals to 1 minus 1 over r squared. Okay, then we used the trigonometric identity that sinus squared theta plus cosine squared theta equals to 1. Actually, before that, we have here cosine y. We have already found out that y equals to 90 degrees minus x. Here, y equals to 90 degrees minus x, therefore we substituted y by 90 degrees minus x in this equation, equation number 2, and we found out that cosine y is cosine 90 degrees minus x, y equals to 90 degrees minus x, and according to the trigonometric identity that cosine 90 degrees minus alpha equals to sinus alpha, we get that cosine 90 degrees minus x equals to sinus x. So in conclusion, we found out that cosine y equals to sinus x. So we can substitute cosine y in this equation, equation number 2, by sinus x. We did it, and we got here that cosine y is sinus x, and it is equals to 1 minus 1 over r squared. This is according to equation number 2, and we have already found out that according to equation number 1, cosine x equals to 1 minus 2 over r squared. In the next step, we defined 1 over r squared is t, and we substituted 1 over r squared in those two equations by t. So in equation number 1, we have cosine 1 minus 1 over r squared, and 1 over 1 r squared is t, so we substituted it by t, and we found out that sinus x equals to 1 minus t. And in this equation we have cosine x equals to 1 minus 2 times 1 over r squared, and 1 over r squared is t, so we substituted 1 over r squared by t, and this expression in total, this expression equals to minus 2t. Okay, so according to equation number 1, we found out that cosine x equals to 1 minus 2t. Okay, so we have here two equations for the expression of sinus x and cosine x. Then we used the trigonometric identity that sinus squared theta plus cosine squared theta equals to 1. So here sinus x equals to 1 minus t. Therefore sinus square x must be equal to 1 minus t squared plus cosine square x. Cosine x equals to 1 minus t, therefore cosine square x must be equal to 1 minus 2t squared. That is equal to 1 according to this trigonometric identity. Then we open the bracket on this side of the equation number 3 and we found out that 1 minus t squared equals to 1 squared, that is 1, plus t squared minus 2t. We open the brackets of this expression also. 1 minus 2t is 1 squared, that is 1, plus 2t squared, plus 2t squared, that is 4t squared, minus 2 times 2t is minus 4t. And it is equal to 1. So here in this of the equation we have t squared plus 4t squared is 5t squared. We have also minus 2t minus 4t is minus 16, and we have 1 on both sides of the equation, so those two ones will get cancelled and we left only with this one. So it is plus 1 equals to 0. Again, according to equation number 3, 5t squared minus 6t plus 1 equals to 0. Then we substituted minus 6t by minus 5t minus 1t, and found out that 5t squared minus 6t, that is minus 5t minus 1t plus 1 equals to 0. Then we took out 5t as a common factor from those two expressions. So inside the bracket we have t minus 1. Then we took out minus 1 as a common factor from those two expressions. So inside the brackets we have t minus 1. This is equal to 0. Then we took out t minus 1 as a common factor from those two expressions. So inside the brackets, so t minus 1 is taken out as a common factor. So inside the brackets we have 5t minus 1. So here we have two solutions that are possible for this equation and also for the value of t. Either t minus 1 equals to 0 or 5t minus 1 equals to 0. So according to the first solution, t minus 1 equals to 0, it means that t equals to 1. And according to our definition, t equals to 1 over r squared. So we substitute t in this equation by 1 over r squared. So t is 1 over r squared. That is equal to 1. We multiply this equation by r squared and found out that r squared equals to 1. We took a root off to this equation and found out that r equals to the square root of 1. We have two solutions that are possible. The square root of 1 could be either minus 1 or 1. But the possibility that r equals to minus 1 is not correct because r is a length and the length must be a positive number. Therefore we cancel the solution and the solution is left only with the solution that r equals to 1. And according to the second solution we have 5t minus 1 equals to 0. It means that 5t equals to 1. We divided this equation by 5 and found out that t equals to 1/5. Okay. Then we substitute t by 1 over r squared and we found out that t 1 over r squared equals to 1/5 because multiply this equation and we found out that r squared equals to 5. We took a root from this equation and we found out that r equals to the square root of 5. The square root of 5, we have two solutions for the square root of 5. Or r could be equal to the positive square root of 5, or r would be also equal to the negative square root of 5. If r squared equals to 5, r could be equal to either the positive square root of 5 or the negative square root of 5. But the solution that r equals to the negative square root of 5 is not correct because r is a length and length must be a positive number, so we cancel the solution and we left only with the solution that r equals to the positive square root of 5, and here we found out that r equals to 1. So we have here two solutions. In the next step we focus to on the drawing, on the original drawing, we have code dB that is equal to 2 units. Because of the fact that code dB doesn't pass through the center of this circle, that is to say it doesn't pass through point O, code dB is not the diameter of this circle. Why? Because any diameter of a circle must pass through the center of the circle. That is to say from point O. So dB is not the diameter of the circle. And we know that the diameter of any circle is the longest chord in the circle. Therefore, the diameter 2r of this circle is greater than dB that is not the diameter, because the diameter is the longest chord. So, we found out that 2r, that is the diameter, greater than dB that is not the diameter. But it is given us the question that dB equals to 2 units, so we substitute dB by 2 and found out that 2r is greater than 2. We divided this inequality by 2 and found out that 2r over 2 is r and 2 over 2 is 1. So r, the radius of our circle, must be greater than 1 unit. Therefore, it cannot be equal to 1. So r equals to 1 is not correct, because r must be greater than 1. We cancel this solution and we left with the only solution, with the second solution, that r equals to the square root of 5 units, or in terms of numbers it is equal to 2.236 units. Okay? Thank you very much.